All right, ladies and gentlemen, this is Mr. Zabo. We are on to section 12.3, surface area of circular solids. Our primary focus today on these notes is going to be finding the surface area and lateral area for cylinders, spheres, and hemispheres. So let's start with lateral area for a cylinder. We call lateral area for a cylinder CH, or the circumference times the height. Remember, circumference is 2 pi r, or pi times the diameter, and the height is the distance between your bases. What you've got to be careful of is how all that plays out. So if this is our cylinder, the radius is going to be one base, the radius of one base, or the diameter of one base, for pi times diameter, and height is how far apart your two circles are. But if we unroll that cylinder, kind of like a soup can, take the label off the soup can, this longer edge of the rectangular edge becomes 2 pi r, and the shorter edge in this case becomes the hypotenuse, or becomes the height, the distance between your two circular bases. So what we would say is the lateral area is going to be equal to circumference, which is 2 pi r, times the height, or just 2 pi r h. That's often the function or the equation that we're going to use for lateral area. When we start talking about total surface area or surface area, just like everything else we've done, it's combining our lateral area plus the area of our base. But we have two bases in this case. They are both circles, so it's 2 times the area of the base. Just like with prisms, except now our circles are the bases and not any kind of a polygon. If we took this all out down to the variables RH, we would have 2 pi RH for the lateral area plus 2 times pi r squared, the area of your base. Go ahead and take that introduction and give examples 1 and 2 a try. Find the lateral area and surface area. Press pause, try the problems, check out the answers. Alright, for example 1, things to look out for. Make sure you have the same units. In this case, our radius was 4 inches, the height was 0.5 feet. I converted feet into inches. We can't do this calculation accurately unless we have the same units. You could have converted the 4 inches into feet and used decimals. Also would have been fully acceptable. Okay. Once we convert 0.5 feet into 6 inches, it's easy to go ahead and do our multiplication. Okay. Area of the base is 16 pi. There are 2 of those. Plus our 48 pi, we get 80 pi inches squared. And for example 2, the circumference is 10 pi. The height is 24 centimeters. It's a 5, 12, 13 right triangle times 2, giving us a 10, 24, 26 right triangle. Therefore, the lateral area, 240 pi centimeters squared, plus 2 times the area of the base for our surface area. Before we do the next part of section 12.3, the lateral area of a cone, let's recall when we were talking about a pyramid, so one base that's a polygon, the lateral area is half the perimeter of that polygon times the slant height. Well, similar concept is true now with a cone. We have the lateral area of a cone is going to be half the perimeter, but the perimeter of a circle is its circumference. So it's half of the circumference times the slant height. Another way to look at that is we have, do this in gray, we have 1/2 the circumference, which is 2 pi r, times the slant height, but half of 2 pi r is just pi r L. So we would say it's pi r L, or pi r times the slant height. Then our surface area is the same concept. It's our lateral area plus the area of our circular base. So go ahead and press pause. Use those and our concepts that we've talked about to do the 2 direct examples here, example 3 and example 4. Then we'll talk real quick about examples 5 before we get into spheres and or hemispheres. Alright, so no trick for number 3, where radius is 15, slant height is 25, lateral area is pi RL, and the base is pi r squared, so pi times 15 squared. Go ahead and get our calculations. Okay. A couple of small things with example 4. If you haven't tried it, go ahead, press pause, and finish that one up. Alright, first thing, making sure that we took the radius of 4, not the diameter of 8. Second tricky part here is to make sure that we identify the slant height as 8.5. That could have been Pythagorean theorem, or recognizing that this is an 8, 15, 17 right triangle cut in half, 4, 7.5, then 8.5. That allows us to calculate our lateral area and substitute that in to calculate our total surface area. Alright, so real quick with example 5, remember we talked about this. Surface area is only the surface that you can touch. So while this is a cone, for my cone I cannot touch the base. I only want the lateral area. And for my cylinder, it does have this base on the bottom here that I can touch, but I can't touch the base on the top. So for the cylinder, we are going to calculate the lateral area plus the area of just one base, not both bases. This is the base that I cannot touch in the cone or in the cylinder. So if you haven't done it, go ahead, press pause, and try to make this calculation. So in doing our calculations here, we wanted to find the lateral area of the cone. Well, the radius for both the cone and cylinder is 3. That makes the slant height 5. It's a 3, 4, 5 right triangle. And pi RL is 15 pi. For the cylinder, the lateral area has a height or distance between bases of 8. 2 pi r times h is going to give me 48 pi. We only have one base that we're worried about, so I only have to add 9 pi for a total surface area of 72 pi units squared. Well, last but not least for the day is talking about a sphere. When we are dealing with a sphere, our formula is 4 pi r squared. There's no lateral area of a sphere because there's no true base for a sphere. Okay. However, when we're dealing with a hemisphere, if it's a part of it that we can touch, this base in this case, let's show that a little different. So if I highlight this base, that's something that can be touched. That has to be counted in my total area. So I'm going to include this. I'll call it a base, even though it's technically not a base, but include this circle part here as a circular base. And we'll try to spell that right. And so I will want to do half of my surface area formula, well, half of 4 pi r. If I want the surface area of the hemisphere, it's going to be 2 pi r squared. But then I have to include that area of that base, which is another pi r squared. So as long as it's a hemisphere on its own, just kind of isolated, it becomes 3 pi r squared. In this case, our radius is 5, so we have 3 pi times 5 squared. We get a surface area of 75 pi inches squared. Okay. Again, this is a hemisphere on its own. It's an isolated hemisphere. However, when that hemisphere is on top of a cone, for example, we have like this ice cream cone type information, we're not going to include that circular quote-unquote base because that's not something we can touch. So in this case, when I'm calculating the surface area of my hemisphere, I only want 2 pi r squared, half of the sphere. And when I'm calculating the surface area for the cone, I technically only want the lateral area for that cone, which we've already talked about. Lateral area for a cone or a pyramid is pi times the radius times the slant height. In a problem like this, radius is 4. That's all I need in the slant or in the surface area of the hemisphere. And in the lateral area of the cone, I need the 4, but I also need the slant height, and that's the one piece that I am missing right now. We know the height, or the altitude there, is 10. We know the radius is 4. We can find the slant height using the Pythagorean theorem. The slant height squared is going to be equal to 4 squared plus 10 squared. The slant height squared is going to be equal to 116. So the slant height is the square root of 116. We do want to simplify that and provide an exact answer if at all possible. Well, 116, the only perfect square factor is 4. So that becomes 4 times 39. Slant height is 2 square roots of 39. Now that I have that, 4 times 2 root 39 times pi, I'm going to get a lateral area for my cone of 8. Here's how we're going to write this. 8 pi square root 39. You're going to not put pi afterwards. The square root, your radical term, is always going to be the last term. And not 2 pi times 4 squared, but 4 squared 16 times 2, we get 32 pi. We get a total surface area of 32 pi plus the 8 pi square roots of 39. That's an exact answer. I'm going to leave it at that. Call it centimeters squared and be done. Again, if it asks for an approximate surface area, I'm going to round that. But if it doesn't ask for that specifically, we're going to leave it like this. All right, go ahead and take some time. Ask the teacher if you guys have any extra questions or if you have any follow-up. Go ahead and get to work on the homework.